All right, we're on to a few more, a little bit more challenging questions, but really still right-angled trig. It's just that we might have two triangles, and in order to solve for whatever angle or side we're asked for, we might have to work in one triangle in order to get to the next one. So we're just going to do a bunch of different examples here. Still need to remember your trig ratios. So fast way of remembering is that abbreviation. Totally up to you if you want to use that. It's kind of what do you call it, an acronym. So SOHCAHTOA. It's an easy way for me to just write out in this video so that we can refer back to that rather than looking at the actual formulas. You need to know how to use those formulas though. So I'm just going to change to blue here. So we've got really one big triangle cut into two parts. And so when it's cut in and you see a little 90-degree symbol, you know that's a 90-degree angle, and this one would be a 90-degree as well. Just based on the fact that that's a vertical line there and a horizontal line there. And this is a straight edge, so it's got to add to 180. So we want to find the length of AB, so this whole distance from A to B, rounded to the nearest tenth. So if it's split for you, we can find this distance here. Okay, I'm going to call that X. And then this distance here, I'll write it underneath, and I'll call that Y. And then we'll add them together. Okay, so I apologize for my messy writing. I have to use a mouse, but still can figure it out. I'll just write a little bit bigger. So take a look at your right triangles. Remember, you need to know two sides to get an angle. You need to know an angle and a side to get another side. So in this case, we know a side and an angle, as well as obviously the 90 degrees. So that means we can find X. So take a look. X is touching the 30, so that's your adjacent side. And the 50 is the opposite. Okay, so opposite over adjacent is tan. So tan of 30 degrees is 50 over X. Now, when you have an unknown that's in the denominator, be really careful. It needs to be, we need to solve for X, which means we're going to have to divide. So I'll show it to you here, we need to multiply through by X on both sides so that those divide out. So then we get, let me go here. So you're going to get X tan 30 degrees equals 50. So then when we solve for X, it's going to be 50 divided by tan of 30. Okay, so whenever you're looking for a side that's in the denominator of your trig ratio, you're going to end up dividing. And you're going to divide by the trig function. Okay, so that's X. I'm going to leave it like that for right now, because that's exact right now. Then let's do calculate Y. So take a look here. We have 40 degrees and we have a side. So again, we can use trig, and it just so happens this side, this height, is opposite 40 as well. And this would be your adjacent. So it's actually a very similar calculation. So now tan, in this case of 40 degrees, is 50 over Y. So to get Y by itself, multiply Y both sides, divide by tan 40. So this will be 50 over tan 40. Okay, so AB then is X plus Y. And so X is 50 over tan 30. and y is 50 over 10, 40. So get out your calculator. I have this big version here, and so I'm going to enter. So I'm just going to move it up a little bit if I can. Maybe I can't. In any case, this is going to be, just give me 1 second. Okay, so I think I got my calculator going here. So we have, first thing is 50 divided by tan of 30. Now, what you want to make sure, close the brackets on that, go to your mode key and make sure you're in degree mode. So go down where it says radians, mine's in radian, and go cursor to the right, enter on degree. Once you reset your calculator, it does go back to radian mode. So just quit out of that. Now I can press enter, or you can add the next term. So I'm gonna do it both ways. So there's the first term, and then 50 divided by tan of 40. Okay, and then I can add them together. If you have a newer version of the calculator, you can go up to the top, enter on it, and then plus the last one and enter. Okay, so whenever I show my work, I show a few decimal places for trig, at least 3. So I'd go 86.603. Give me a sec here. So this is equal to 86.603 plus the next one was 59.588. 59.588. Now you don't have to show the decimals in between. You can just add them together. And then the final is 146.190. 146.190. And then I round from there, 146.2. So if you were to do it separately, if you didn't have a graphing calculator and you had to use a scientific calculator, show at least 3 decimal places, then round to the 1 that you're asked to here. And this is in centimeters, so you also need units. I always suggest 2 more decimal places than what you're asked to round for each sort of part of your question, and then round at the end. Okay, part B says determine the area of triangle ABC, rounded to the nearest whole number. And so this is why I like to record the lengths, or whatever the answer is, to a few more decimal places. So I have it in case I clear my calculator, because I don't want to use the rounded part here to calculate the area. So area of a triangle, remember, is base times height divided by 2. All right, so the base is what we just calculated, and that's where I'm going to use my value that's rounded to 3 decimal places. And then height is 50, so multiply by 50, and then divide by 2. Okay, so now in my calculator, I have the 146.190. I have it to more decimal places, so use it if you do have that. And then just press multiply by 50 and then divide by 2. Okay, so 3,654. Now that's the last part of this question. So now I can just round and show it to 1 decimal place now. So 3,654.8. And units are centimeters squared. Okay, on to the next one. 54. Second one, determine the measure of angle SPR. So SPR is this angle here. You might want to call it something different like theta. It's just easier than using 3 letters. And then at the end you can put that back in. Rounded to the nearest degree. So take a look in that right triangle. So this has 2 right triangles as well that share a side, but it doesn't form a triangle on the whole shape. It's a quadrilateral. So here in this right triangle we have this side, so we have a leg, but we don't have the other leg and we don't have the hypotenuse. So we don't have enough information. We're also asked to find an angle, so really we need 2 sides. So always look at the shared or common side. So can I figure out what PR is? If I can, then I'll have 2 sides and I can figure out what theta is. So take a look at this bigger triangle. I have, it's 90 degrees, I have an angle of 28, and I have a side. So that means, yep, I can find this side here. So compared to 28, this is your opposite, and this is the hypotenuse. Okay, so opposite over hypotenuse is sine. So sine of 28 equals opposite. I'm going to call that, actually I'll use the 2 letters for now, PR. You could call it X if you wanted. So PR over 18. And so PR, so remember, if your unknown's in the numerator, you're multiplying. And I always show the side out front, not after the angle, because then it gets a little confusing, especially with some people's writing. And if you forget the degree symbol, then you really wouldn't know what it was. So this is 18 times sine of 28. Okay, and that you can keep it exact, but I usually find out what that is to a few decimal places. So clear off here, 18 sine of 28. And so that's 8.45, let me just check that again, 45048. So I'm going to go a few decimal places just because, actually no, I'll have it in my calculator. So 450 is to 3 decimal places, just like the last question. Then, so now I know this side, right? And so compared to theta, this is adjacent. And this is now the hypotenuse, okay? And I know it. So adjacent over hypotenuse is cosine. So cosine of theta is adjacent, which is 6, over hypotenuse, which is 8.450. Or you could show it as 6 over 18 sine 28. If you wanted to do everything in one step, okay? And so then remember, to get an angle, you press the second key, so it's going to be cos inverse of 6 over 8.450, or that, okay? And so in your calculator, what's great is if you have a, well, I think you all have graphing calculators, but what's great is you already have the denominator there. So when you go second cos, then you're going to go 6 divided by, you can either do cursor up. If you have an older version of the calculator, you can go second negative. That gives you the answer. See how it says answer on your calculator. Close the bracket, enter on that. Okay, and this says nearest degree. So again, I show a few decimal places, 44.764. And really, this is more for my purpose is when I go back to check, because there's no part B in this one, so I really didn't have to show 3 decimal places. But now it's 44 point, oh sorry, what was it? Nearest degree, so 45 degrees. Okay, so that was question 2. Let's go to the next one. This says determine the measure of angle CBE. Oh, actually, before I finish the last, I called it theta there. I'm going to go back. What did the question ask? It asked for angle SPR. So therefore, angle SPR is equal to 45, right? So just to keep it in the same notation. Okay, so now question 3, determine the measure of CBE. So that's this big angle here, rounded to the nearest 1/10 of a degree. So this is a big triangle. It's cut into 2. The whole big triangle is a 90 degrees, as is the little one. This one here, if we look at separating it, it's a triangle as well, but it's not 90 degrees. It's an oblique triangle, and we'll actually learn different ways of solving these types of questions once we learn the sine law and the cosine law, because they're for oblique triangles. But for right now, we have to keep to 90 degrees. So we want to find this angle. If we were to know 2 sides of this big triangle, then we could find it. So we know this side, but we don't know this entire side here, CE. So what about if we could find this? I'll call it X. Actually, I'm going to call it CD, just to keep it using those letters. Okay, so if I, sorry, just got to go back here, press that by mistake. So I want to find CD. And take a look, I have 2 sides, it's a 90-degree triangle, so I'm going to use Pythagorean theorem because I don't know any other angles. So CD is a leg, so CD squared is equal to the hypotenuse squared minus the other leg squared. Okay, so that's going to be 225 minus 169. I want to just make sure I do this. So 225 minus 169 is 56. Okay, so CD is root of 56. Okay. You can simplify that, but we're not done the question and we're not asked for that side, so I'm not going to bother simplifying it. I'm going to label it here just to make sure. And then that means my CE is root of 56 plus 6. Okay, now if you wanted to find the decimal form, maybe you would do that now. So root of 56, cursor out of that, plus 6 is 13.483. Don't clear your calculator unless you really need to, because then you can go back and use some of the values you found. So now angle CBE, which for right now, because it's 3 letters, I'm just going to use theta there, is going to be, I know now this whole side CE, which is opposite, and I know the 13, which is adjacent. So that's tan. So tan of theta equals, now if you want to keep it exact, you can go root 56 plus 6, that whole opposite side, over the adjacent, which is 13. So to get theta by itself, it's inverse tan. So second key, tan key, and then root 56 plus 6 all over 13. Okay, so calculator out. Maybe I'll move it this way. Okay, so because you already have some the numerator in there, you could use it. So you could go second tan, that answer, okay, or cursor up if you have a newer calculator, and copy it out, divided by 13, close the brackets, enter, okay. You could also do it all in once, so second tan, and then if you have the ability to do a fraction, you could do the fraction and do root of 56, cursor out, plus 6, cursor down, 13, cursor to the right, close the brackets, enter. Okay, so a few different ways. 46.046. 46.046 degrees. That's theta, and it says to the nearest tenth. So, and then I'm going to go back and call it by the letters that are used there. So angle CVE equals 46.0. Okay, to the nearest tenth. So that's question 3. All right, this is a common type of question. So it says, from the top of an 80-meter tower, Sam spots 2 fires, one behind the other. If the angles of depression of the 2 fires are 10 degrees and 18 degrees, determine the distance between the fires. So really what we're looking for is this distance here between those fires, okay? Not the whole side of a right-angled triangle. So again, we might be able to do this question a little bit differently once we learn sine law and cosine law, but for right now, we're going to use our 90-degree triangles, so you can kind of put a 90-degree symbol in there if you want. You know this is 80. And then angles of depression, remember that's from the horizontal. So I'm actually going to just draw a line like this. So there's a horizontal line, and so the angle of depression is from that downwards, okay? So the smaller one is 10, and then the bigger one is 18. Okay, now those angles aren't in the triangle, either triangle, but hopefully you remember your parallel lines theorems from junior high. So if you have 2 parallel lines, this is parallel to this one, then these corresponding angles will be equal. So here, this 10 will be 10 here. And this 18 will be 18 here. They form a Z when you graph them, right? So if I go across and down and across, it's a Z, and so that 10 has to equal this 10. Actually, they're not corresponding angles, they're alternate interior angles. So when they form the Z, alternate form an F. In any case, they're equal between those. So now we do have angles in a triangle, the bigger one and the smaller one. And so if we could find this entire length here and then subtract this, we'll get X. Okay, so we have a side and we have angles. That's all we need to get another side. So I'm going to call this, how about I call this Z and this Y. So my outside, my bigger triangle, to get z, so I'm going to have tan of, and there's a couple ways, I'll show you something else as well. Tan of 10 is 80 over z. So that means z, I'm just going to do it sort of horizontally so that we run in a space. So 80 over tan 10. Okay. And then you could find the exact value. We're going to wait for right now, just like we did before. Then the inside triangle, that's tan of 18 equals 80 over y. So y equals 80 over tan 18. Okay, and then we'll subtract them. So x will be equal to z minus y. So that's going to be 80 over tan 10 minus 80 over tan 18. Okay, so get our calculator out. I'm going to go to the right here. Okay, so if you want to do them separately, say you don't have a graphing calculator, so do that, tan. And if you want to do fraction form as well, now that depends on the calculator, but second y equals, enter on fraction, and you can go 80 and then cursor down for tan of 10. Close the brackets, cursor out of that, minus, and then a fraction again, 80 over tan of 18. Okay, so final answer is 207.488, 3 decimal places. Okay, and that's the distance. It doesn't say what to round to. So normally for distances, we go to the nearest tenth. So that would be 207.5, and that is meters. Okay, because the height was given in meters. Now, if you wanted to do this individually, this different parts, I'll just do that quickly. So you can also, just if you don't know on your, if you have a newer calculator, you can copy that out and then basically, oops, cursor to the, let's see if we can delete all of this. Yeah, we can kind of delete all of that. Okay, and enter, and that's 453.703, 453.703, and then the other part, again, I could copy that out, and then delete everything to the left, and then enter on that, 246.215. Okay, if you did do it individually. Okay, so sometimes you're going to have to find outer portions and subtract, and the biggest thing here, angle of depression, is not these angles at the top here inside the triangles. They're outside the triangles. So if you wanted to, what you could do, I'm going to do it in red here. If you knew the angles of depression, then you could label this angle here. If that's 10, then it has to add up to 90, so that would be 80 degrees. And then this one here would be 90 minus 18 would be 72. Okay, so then what you could do is your Z, so here we would still use tan, but for our outside triangle, we would have tan of 80 equals Z over 80. Different 80, right? That's meters, this is degrees. So Z would equal 80 times tan of 80 degrees. And then your inside triangle, that would be tan of 72, would be Y over 80. And so Y would equal 80 tan of 72. And so let's quickly just do that on the left. So we would want to add, subtract those, right? The Z. So we'd go 80 tan 80, close the brackets, minus 80 tan 72. Okay, and 207.487, same as what we had up there. Okay, so that's an alternate method. Okay. All right, next one. So this is also a common type of question. So Sam's condo apartment on the 15th floor of a tall building has a nice balcony. There's Sam on the balcony. One day while on his balcony, Sam looks closely at a nearby office tower. He notices that the angle of elevation of the top of this tower is 54 degrees and angle of depression to the bottom is 30 degrees. Sam's building and the office tower are 60 meters apart. Determine the height of the office building. So the biggest thing, we kind of have to label some stuff, right? So from the horizontal, that's Sam. We've kind of helped you with the line of sight here, but I'm going to draw in that line and then label, maybe I'll do it in red. So angle of elevation is 54. So that's from the horizontal up. Angle of elevation and depression are always from the horizontal. Okay, and then to the bottom, this is 30. Okay, and then the distance across, so this distance here is 60. Oops, not straight, but that also means that this is 60. Okay, and this means we're assuming the buildings are at 90 degrees, right? So we have one side and we have an angle. We have one side and we have an angle, and we want to find the entire height here. So really, if I call this part X, from there to there, okay, and this part Y, then height is the total of those. Okay, so let's do X first. So again, we're doing tan. A lot of applications end up using tangent. It's just the way. Really, hypotenuse, we don't have a lot of measurements, and we're often trying to find the hypotenuse. So tan of 54 is equal to X over 60. So X equals 60 tan of 54. And then tan of 30 equals Y over 60. So Y equals 60 tan 30. And so the height is X plus Y. So again, we can just do it all in one step rather than finding the decimal form of each, having to round. So we can go 60 tan 54 plus 60 tan 30. Notice when it's ones like this, you could actually factor out the 60, right? And go 60 times 10. So I'm going to show that to you. Not that we do it that often, but you could go 60 times tan of 54 plus tan of 30. Remembering those factoring skills, right? In any case, so that's kind of, just remember that. We'll get our calculator out, move it over this way. So 60 tan 54 plus 60 tan 30. Just remember to close your brackets around your angle, because otherwise it'll put the 60 tan 30 in with that angle. Okay, and that's 117, I forgot to look here, 0.224. And doesn't say what to round to, so we'll go to the nearest tenth, 117.2, and that would be meters. Okay, so that one's pretty straightforward. Just always remember, angle of elevation is from the horizontal up, and angle of depression is from the horizontal down. Because sometimes we won't even give you these dotted lines either. Okay, so that is a good sampling of some two triangle problems. That's it.